It's time to chill out and get ready for a mediocre Q&A live stream. If you're old enough, grab yourself your favorite adult beverage, and if you're not, stick with apple juice. Put your feet up and relax. If you have any questions, feel free to ask them in the chat. And now let's cue up the intro music.
What's up, ladies and gentlemen, guys and gals out there? This week, I'm going to be changing my name to the Curious Computer Hacker Guy. Now, a lot of you guys probably wouldn't have guessed this, but Chris isn't very good with his password, so I just happened to be able to hack into his computer tonight. And if you guys want to know, his password is actually Unicorn Princess, so that's why I'm here. I decided to take over for a while. So tonight, I am going to be your HVACR videos guy. As you can tell, I am Chris Stevens, right there. No, right there. Yeah, right there. So Chris Stevens, that is how you spell his name too, with an F and an S. So tonight, we're not going to do any of this boring stuff that Chris always talks about with his refrigerators and TXVs and whatnot. Instead, we're going to do something much, much more fun. We're going to talk about Michigan mechanical codes. I'm sure all of you guys are really interested in boiler top clearances. I mean, who's not interested in that? Boiler connections, valves. I know Joe Canada, Adam, even probably Justin Beaver, all there. You guys are probably going nuts with this right now. Hot water boiler expansion tanks. Now, if you guys do get bored of me reading you the International Mechanical Code or Michigan's Mechanical Code, after that's done, I got my Rubik's Cube. So you guys can watch me try to figure out this Rubik's Cube. Let's get that started first, because nobody really tunes into these to really learn about anything. They just tune in here just to talk in the chat. Let's be honest, right? Nobody wants to tune in and listen to Chris babble on about refrigerators and all that magic nonsense. I mean, what is a TXV really? Nobody even needs TXVs. I mean, really, if you ever are in a situation you have to replace a TXV, all you got to do is take, we'll say a 1/2-inch piece of copper, and you crimp it down, not all the way. You crimp it down just so it's just barely open. Boom, right there. TXV, problem solved. So you guys can take that one to the bank right there. I learned that from Sporlin, Captain Sporlin himself. So now, if you guys ever do find yourself trying to solve a Rubik's Cube, the first thing you want to do is try to get these white ones in place, right? So we go like this. Then we go like this, see? And we got the white one right there, right? Now we got to do our green one. Now, if you guys do decide to unfollow Chris because this channel is boring now, you guys can always head over to this guy right over here in this corner. Let's see if I can get right there. Curious HVAC guy. I don't know him, but he does a pretty good job, I hear. As you can tell, I'm Chris Stevens. So you guys should probably just unsubscribe from Chris Stevens' channel and then just go right over there and just totally follow that guy. He's cool. He's got an awesome voice and a beard. And yeah, he does basically the same thing, just does it a lot better, you know? Does it a lot in a much cooler way.
So how much do I got to pay you for this, Bill?
Hey, well,
Can I have my stream back,
hey,
please?
son. Wait, can I swear on this? What the hell? I thought I had you locked out. I went in here and changed your password even.
This is not brought to you by Sporlin.
Your password is now password instead of Unicorn Princess.
Would you have to share that with everybody for?
How do I lock you out of this?
All right, I'm gonna take this back over. I want my stream back. There you go. Get the hell out of here, dude. All right. How you guys doing this evening? Hopefully you guys are doing well. Obviously, if you guys don't know who Bill is Curious HVAC guy. Cool dude. Definitely check out his channel. Highly suggest it, guys. As usual, we just thought that would be kind of funny having Bill come in here, but he's a cool dude. He has lots of great videos on his channel, so definitely, guys. If I try to post a link, maybe we'll get the link posted in towards the end, but obviously just look up Curious HVAC guy on YouTube, okay? Definitely good stuff to catch. Couple different topics we want to talk about tonight, and then we will get to your guys' questions as usual. And let's see if I can click this silly thing. There we go, right there. There we go. You guys don't need to know my name because you know who I am. So, all right. No, I do not have comedy on my channel. So, Bill's the funny dude. I'm not funny at all. I'm all serious and all about business. So, all right. So, a couple different topics I want to cover tonight, as usual. And then, like I said, we'll get to your guys' questions. So, one of the things that I have constantly, and I've explained this so many different times, okay, that I just want to try to do it again, okay? So air balance. I am not a certified air balance technician, okay, but I know enough to get me in trouble, and I constantly get the question, what is air balance? Why do we need exhaust fans? You know, why do we need makeup air? What's the difference? So I know I've talked about this probably a bunch of times. I'm just going to go over it really quick. I have a really easy explanation here for air balance, okay? Right here, paper bag, okay? What you do is you take some spray paint, you spray it in the bag, you put your mouth, no, I'm just kidding. But, so paper bag, just a silly paper bag here, and this is just going to, you know, just give you an example of air balance and how it works, okay? So if you take a paper bag and you put it over your mouth and you suck, the bag collapses, right? Okay, if you take that same paper bag right here, cut a perfect hole in the bottom of it, all right, and you suck through the bag, nothing happens. The bag doesn't collapse, okay? I know that's silly, it's simple, but it's the easiest way for me to visualize air balance for people, okay? If you are using exhaust fans to pull smoke out of a building, all right, whether it be medical, whether it be kitchen, whatever. If you're using exhaust fans to pull smoke out or unwanted air, you got to put air back into the building. You have to balance that out. We do that with makeup air. Okay, oftentimes we have dedicated makeup air units. The dedicated makeup air units basically supply air into the building to make up for what the exhaust fans are pulling out. All right, if you have a building where the exhaust fans are pulling all the air out, okay, then the building becomes negative, meaning that the doors are hard to open, different, you know, and when you do get the doors open, you're going to get a blast of unconditioned outside air coming in through the doors because you got to make up for what the exhaust fan pulls out, all right? So therefore, we're going to use a makeup air unit. Oftentimes, we'll use, like I said, a dedicated makeup air unit, but with most restaurants these days, they're only going to pull about 80% of the needed makeup air through the makeup air unit, and then they're going to pull the other 20% typically through the RTU units or air conditioning units via outdoor air dampers, different things like that, okay? That way they can bring fresh air in to help satisfy CO2 requirements. Okay, one of the ways that we measure for one of the ways that we measure the amount of people in a building, because we have to do air exchanges for every single person to bring in fresh air into the building, is by measuring CO2. So but there's all kinds of different crazy stuff with that. And again, probably need to get someone a little bit more qualified to talk about that. But that's the simplest way to explain why we have to have a makeup air unit and why we have exhaust fans, okay? Next, I want to, and I'll definitely get to your guys' questions in the chat, to do me a favor and put them in caps lock, and that way we can see everything in there, all right? On my list here, I had posted on social media today about an ice machine that I was working on. I was working on a Hoshizaki ice machine, and one of the questions that I got with that post, I posted it on Instagram, and one of the questions that I had gotten was why I invert my recovery tank when I recover gas, or when I push gas into the recovery tank. Okay, so a while back, Appion, the vacuum pump and recovery machine manufacturer, had posted a little link, and it kind of made sense to me. And what they said was that on a recovery tank, okay, there is you've got your valves right here, and on the valve, this is your dip tube, okay, and this is what separates the liquid from the vapor port, okay, is this dip tube. Well, this dip tube is very small. If I can get it off here, okay, it's actually, you can't see that through the camera, but it's actually, the diameter of this is actually smaller than 1/4 inch. And so Appion had posted this link saying that you should invert your recovery tank if you want to, and charge the, push the gas in from the recovery machine through the vapor port, instead of trying to push the gas in through the dip tube, because the dip tube creates more of a restriction. So that's why people always see it in my videos and my posts, that when I'm recovering gas, I'm hooked up to the vapor port, and I usually invert my tank, okay? It's just because of a way that Appion had said that it makes it go faster. Now, I have no scientific evidence saying that it does go faster, so one of these days I'll do like an experiment where I have 2 recovery machines. I have to basically have 2 of the same recovery machines, 2 of the same tanks, same temperatures and all that good stuff. And I'll see if there actually is a speed difference. But I feel like there is a difference in the way that or in the speed of the recovery, basically, by hooking up to the vapor port. Another thing that I wanted to point out too, and I am going to actually, yeah, Bill, welcome to the chat, Bill. What I'm actually going to do here real quick is share a little clip here. Well, actually, I don't even need to share a clip. I could just tell you guys. Oh, no, I will, because it'll kind of explain something here. So let me change this over. Nope, that's actually not going to work. So no, we're not going to share the clip right now. Actually, sorry, technical difficulties here for a second. Let me see if I can figure this out. Let's see. Well, yeah, we are going to share the clip right now. So hold on just a second, and I'll go ahead and transition that over, and I'm going to play this for you guys real quick. Just a quick tip here. You can't trust the colors on recovery tanks, because if you look at this one, red is liquid. If you look at this one, blue is liquid. Red is vapor. 2 recovery tanks. For whatever reason, different manufacturers use different colors. So you can never trust that. You got to read. So don't just look at the colors and think you got liquid and vapor. Always pay attention to that. Well, I don't think that quite worked out the way that I wanted it to, because I know that the screen wasn't showing quite right. But again, sorry for the technical difficulties. But the whole point is that 2 identical recovery tanks sitting next to each other, the red and the blue are not always going to be the same, whether it be vapor or liquid. So very important to understand that. That's another comment that I get all the time, is people saying, hey, you're hooked up to the vapor. Hey, you're hooked up to this. Well, each tank is different. So you always got to read what it says on there. So in this situation, the blue is vapor, the red is liquid. But on another tank, it won't be. So, it is what it is. All right. Let's see if we got any questions in here. I don't know if I see any yet. Let's see. Probably a dumb question, but how are you measuring the pressure difference between the inside and the outside? Okay, so I'm assuming you're talking about air balance, right? Is it our force C3 JU4, and I don't know what your screen name is there, bud. But what you usually use is you can use a manometer, but it has to be a highly sensitive manometer. But we'll usually measure it in, I believe they measure air balance more or less in pascals, don't they? Again, I'm not a certified air balance person, but the only tool I have on my van is a manometer, so I'll measure in inches of water column and just kind of see. But in all honesty, I'm usually not measuring my air balance because I'm not doing any certified. I'm just kind of winging it and just testing to see if the building, when I'm going to adjust an air balance on a building, I'm just going to make it ever so slightly positive is what I'm going to do. So, but again, I'm not certified in air balance. That's not my job. I've just done, it a little bit here just to get me, out of a bad situation. And then usually I'll let people call a certified air balance company to come in and adjust accordingly after we're done is usually what I do. So have I ever worked with ammonia equipment? Do I recommend learning it? Dawson, no, I don't work with ammonia equipment. Every once in a while, there'll be a gentleman that pops in here. His name is Ulysses Palacios, I believe is how you say his last name. And he works with ammonia, but I don't. Sure, I recommend getting involved in anything you can within the industry. Okay, so ammonia is its own little niche. And definitely, if that's something you're interested in, go for it. Okay, this whole entire industry needs help in all the different sectors we have. So why are liquid receivers so common? I don't understand what you're asking me there, HVAC kid. Clarify your question, bud. I need some context to what you're asking there. All right, let's see what else. What kind of questions are we fielding right now? What kind of questions do you want to ask, bud? Steve Zeller, just go ahead. I mean, it really depends on what you want to ask, man. I mean, HVAC, refrigeration. If I can't answer it, I'll tell you. So I'm not really good at explaining where babies come from, but I kind of have a general concept, I think I can figure it out, but, I mean, just, ask away, bud. All right. Let me see what else. Am I concerned of fractionization when topping off systems with blends? Not really. So our 404A is a near azeotropic blend, if that's the correct way to say it. Maybe my buddy Ralph can answer that question a little bit better than me. But yeah, 404A, you don't really need to worry about it fractionating, I think is how you would say that. It's not really a big deal. So it was a big hype when they first came out with like 410A and 404 and different things like that. But it's the glide on it. You really don't need to worry about it fractionating. So if you have a leak, it's safe to top off the charge. But there's some other refrigerants that can be problematic, but the most common ones that I deal with, 404, 410, and 448A, you really don't have to worry too much about topping off the charge. So, all right, let's see what else. Chris, what was the big announcement? HVACR vlogger. It was just that Bill was going to be on the show, dude. It was just joking around. Me and Bill have just been talking about doing that for a while. So, there you go. See, Dallas fan is Ralph in here, and he's always willing to answer any questions about refrigerants. He works for Honeywell Refrigerant. I'll post his email in here right now, guys. Anybody has questions, ask him. He's the man. All right. Let me see what my next question is here. Can exhaust fans suck out the air from your AC? Can they? Yeah, that's a good question. Pretty Cure Forever. Well, okay, I think I understand what you're asking me. So, yes, typically an exhaust fan is designed with a special hood that the exhaust is pulling out of. Typically, it's not just pulling out of the ceiling. And the way that the hood is designed is that it has makeup air coming into it. So the cooking equipment usually goes under the hood canopy. Again, I wish I had some visuals to show you, but it goes under the hood canopy. And when the heat and the smoke rises, the makeup air kind of creates an air curtain. And it's not perfect, but it tries to create an air curtain that keeps the smoke in the exhaust fan, and the makeup air just kind of recirculates and also gets sucked up, but also replaces what's exhausted. So yes, exhaust fans do, because a building is an entire envelope, so an exhaust fan would pull out conditioned air, so you do have to be careful about that. You have to make the building balanced correctly. Now, if you think about an air conditioning unit essentially is just recirculating air. So at some point, unless you're putting air back in, the building's going to become so negative that it's not going to pull out too much air anymore. And the building's just going to become just this giant negative abyss. But there's always air leaks. I mean, we're getting super techie right now. again, beyond my realm of discussion. But sure, I mean, an exhaust could theoretically pull out conditioned air that you've, put into the building. Yeah. Yeah, it definitely could. The whole point of having a properly designed hood, with the newer hoods for sure, it's going to create that little air curtain, and it's going to keep the smoke and the heat inside the hood canopy, and try not to pull anything else out from the rest of the building. But there's all kinds of different ways about air balancing that you need to understand. Again, getting way technical above my head, and that you can have a perfectly balanced building, but then you could still be pushing smoke into the dining room, or pulling dining room air into the kitchen across the pass out line, which is cooling the food. There's all kinds of things that you have to worry about when you're talking about air balance. It's not just whether the building's positive or negative. So again, going off on a tangent as usual. So let's see what else we got. Do I ask permission to film my videos on my clients' buildings? You notice that I am very careful not to show or share too much. So yeah, my customers typically do know that that I am filming. We try to be careful. Again, still, I want to protect my customers, so I don't let anything be seen. I don't want people to realize what restaurants I'm working at. Now, I do realize that some of you guys that are in the or watching the videos, if you guys work in restaurants, you probably know where I'm working. But yeah, we try not to share that. So, we try to keep it somewhat secret, basically, so that way we protect them. Let's see what else. All right. Steve Zeller, you bought a Supco M500 Megger and was wondering if I use one first and foremost, and ultimately you love it for compressors, but trying to figure out what else you can do with it on one. Okay. So, Steve, be very, very careful about using a Megger on compressors. Okay. A Megger on compressor can be, it's really easy to misdiagnose a compressor. Copeland has a article, and I will try and share a link to that article. Thank you very much for that super chat, Andrew. I appreciate that, bud. Yeah, Copeland has an article. Gosh, I need the tech bulletin right now. I'm going to try to pull it up right now, where basically they tell you that using a Megger on a compressor can be very dangerous, and you need to be very cautious about it. So, oh, thank you very much, Mr. Zach there. It says that you became a member. I appreciate that, bud. All right, let's see what else we got here. Oh, I'll try to share that article. Hold on just 1 second here. And let's see if I can pull up this Copeland article. Sorry about that. And let's see. All I'm going to do is ask the Google for Copeland Megger test. And basically, it's going to come up with an article. And I'm going to share a link in the chat right now. And basically, it says that Copeland doesn't recommend using a Megger for testing for an initial test. They basically say that they want you to use a mega ohm meter to do basically like a trending test. They want you to test it over and over and over again and notice trends in the degradation of the windings. And basically, if you have moisture in the system, it can read like it has bad insulation when it's just moisture. So they say that, like, if you start to notice bad readings, like the windings are going bad, what they want you to do is go ahead and change the dryers, try to clean the system up. If it's possible, remove the refrigerant, pull a good evacuation on the system, repair whatever leaks, recharge it, and then do another Megger test. And notice that the insulation values seem to be getting better, because moisture in the system can indicate, it can give you a false negative, a false positive, basically showing you that it's got bad windings or something like that. So, all right. Yeah, I appreciate you saying they're showing that in there, Zach. I think I need to figure out a way to make the new member little icon, because the whole thing about the members is you get like a little special icon next to your name, Zach, and I need to figure out how to make that bigger. But yeah, all right. So I'm going to share this link in the chat right now, you guys. Do me a favor, copy this link and check it out after the stream. All of a sudden, the whole stream goes blank because everybody clicks the link and it takes them to a new page. Yeah, that's what I get for doing that. Do liquid receivers affect condenser and evaporator capacity? Do liquid receivers affect capacity? I don't think liquid receivers affect capacity. No, I can't see that being a problem. That's an interesting one. I'm try to turn my mic volume up here just in a little bit. Hopefully that makes it a little bit better. Is that any better there? Hopefully I'm not clipping now. Yeah, that should be getting better. I'm seeing the volume come through better right there. All right, let's see what else we got going on. Anyone? Okay, cool. Is it common to perform a temp rise on an RTU and adjust manifold gas pressure according to this? I don't know what you're asking me there, Evan. So definitely, if you could rephrase that, I would try to get to that and answer it a little bit better for you. All right, let's see what else. Okay, I'm going to go to my list of things to talk about here real quick and try to go through it. So guys, what I typically do on these streams is as I get questions and emails, I try to address them in the stream. So I usually have a sheet right here in front of me. Real quick, common things I get all the time, guys. Okay, topping off the refrigerant charge in the United States is perfectly legal. So long as your system contains 50 pounds or less of refrigerant, okay, you're allowed to top off the charge. Once you get over 50 pounds, now we have new laws coming into effect as of the new year, but as of right now, it is perfectly legal for you to top off the refrigerant charge. That is something I get quite often. How can you top off the charge to get them running? That's just how it works. Now, I realize in some of the European countries and some of the other countries around the world, they're far ahead of us, and it is completely illegal to top off the charge. You have to fix leaks and go on. But here in the United States, it is perfectly legal if your system contains 50 pounds or less of refrigerant to top off the charge and then go back in later and try to fix leaks. And in fact, I don't even think we technically have to fix the leaks, but obviously you want to fix the leaks so that way they don't have to keep buying refrigerant. But yeah, that's one of the things I get all the time is people asking me about topping off the charge. Do I work on water-cooled condensers, Isaac? I have in the past. I don't have any water-cooled stuff right now, but I have worked on water-cooled systems. I've worked on systems where they just pump and dump. They pump the water in and then just dump it right down the drain. Those are pretty much, for the most part, outlawed here in California, but we still do have a few people that have the old school pump and dump systems. We also have closed loop systems where we are, basically pumping recirculated glycol and different things like that. We have open loop systems. There's all kinds, but yes, we do have them. I don't work on them very much, so let's see what else. Can I go over Hoshizaki ice machine schematic, Eric? I'm not going to go over the schematic on this, but we can definitely talk a little bit more, Eric. What I'd highly suggest you do is sending me an email to hvacrvideos@gmail.com and let me know what it is exactly that you're wondering about as far as the Hoshizaki schematic. Your question actually segues me into another thing I wanted to talk about is constantly I get people asking me questions and, why they're asking me how come I don't show the entire process in my videos. How come I don't show from step 1 to step 10, how I went through this and did everything. Okay, guys, you have to understand something. My videos are meant for service technicians. I do not want my videos to replace or to take a service technician's job. I do not want DIY people watching my video and trying to fix their own equipment. Now, it's inevitable that some people are going to watch my videos and be mechanically inclined enough to try to figure things out. I can't control that, but I try to do my best to leave certain components and certain parts of my videos out purposely because number one, well, 2 reasons, liability and I don't want to replace or take away from anybody's, work. Okay. So for instance, people ask me, hey, will you show me how to set your pressures on your oxygen and acetylene rig when you go to braze something up? No, I won't, because that's a massive liability if I show you guys how to set the pressures, because what happens if something happens? Okay. I can't show certain things like that. But yes, if you have a specific question about a Hoshizaki schematic, send me an email and maybe it's something I can address. As far as going over schematics on the live stream, it's just going to be too, user specific and it's just going to bore everybody else out. So I definitely see a lot of, hey guys, I see the new people becoming members. Thank you very much. Adam. And then, let's see who else. I see a bunch of people popped in there right now. I'll have to get to them. And thank you guys. They're going by so fast on my screen, I can't even tell. So thank you guys very much. All right, let's see what else. How do I cool a compressor that is getting hotter? There is plenty of oil. Ice Machine Rookie. You ask me, how do you cool a compressor that is getting hotter? Well, it really depends. I mean, compressors do run hot. You need to find out whether it's too hot. That's the question. But compressors aren't cooled by oil. Okay, the oil is running through the system, lubricating the components inside the compressor, okay, to keep them from building up friction and getting too hot, okay? But the actual compressor is cooled by refrigerant suction gas coming back to the compressor. So the suction gas coming back to the compressor is actually what cools the windings, okay? So now, if the compressor was low on oil, sure, the components inside would get excessively hot and it would create extra heat, but there's already heated compression happening inside that compressor based off of the pistons compressing the refrigerant, okay? And that is simply cooled by the suction gas coming back. So if you have overheat issues, it could either be due to lack of oil, it could be a faulty compressor, or it could be that your superheat is too high coming back to the compressor and it's causing the system to overheat. But some compressors also just run hot in general, so it really depends. Let's see what else. What's my experience with Alto-Sham quick chillers? Honestly, Storm, I have no idea. I've never worked on those, bud. Wish I did. So let's see what else here. How do you know compressor running too hot besides it shutting down on thermal? Good question, Justin. That is a good question. So Hoshizaki, or good point, I should say, Justin. I'm sorry, not Hoshizaki. Copeland basically has a check, and they tell you that essentially, I think the hottest you want to see a Copeland compressor is at 225 degrees, I think. You want to take, I think it's 225 if I off the top of my head. The Copeland mobile app would certainly probably tell you. It might not, or you can find a Copeland Tech Bulletin. But basically, you're going to take a discharge line temperature about 6 inches away from the compressor, and I believe they don't want it to be anything over 225, if I remember right, for Copeland scroll compressors. Because after that point, the internals of I think it's like 6 inches away from the discharge or the head of the compressor. If it's 225, then that means the internals are much hotter and it's starting to break down the oil. So, all right, let's see what else we got. Yeah, there you go, Zach. Over 225 is pretty bad. All right, let's see what else we got in here, guys. If I missed your questions, definitely post them in there again, okay, guys? And I appreciate all the people that are becoming new members. Thank you very much. Let's see what else. Yeah, 227. But the interesting thing, John McMaster, is that the 225 or 227 is actually on the outside. The internals of the compressor are much hotter, but that's the measurable temperature on the outside that they know that if it's 225, 6 inches away from the outlet of the discharge, then the internals are like whatever temperature. We should try to get someone from Copeland one of these times to talk on here. So, JYPHC. For those of you guys, if you want to join as a member, so JYCHC, if you look at the YouTube page, there's the ability to join as a member. And essentially, it's like it's supporting the channel just for I think there's different tiers like $1.99, $2.99, different tiers like that. And that's how you join. It just supports the channel. It's just a monthly reoccurring charge. If you guys can choose to cancel it too. So at any time. All right, let's see what else we got going on. What's my experience with epoxy dipped evaporators? Okay. Ralph, you can help with what? What did I miss on that, bud? Anybody, can you clarify what you're saying you can help with, Ralph? Storm, you asked, what's my experience with epoxy dipped evaporators? I have no problem with epoxy dipped evaporators. I have lots of refrigeration evaporators that have epoxy on them. I kind of question whether or not sometimes they make it too thick, and I worry about the BTU or the heat transfer being negatively affected. But everybody that's done epoxy dipping on their evaporators, they seem to say that it works fine. I don't know that it completely eliminates. The whole point of dipping an evaporator in epoxy is that it reduces corrosion for reaching coolers and different things like that. The contaminated air from the vinegars and the salts and different things like that, citric acids and different things in the air attack the copper and deteriorate it. That's why sometimes if you open up like a reach-in cooler evaporator, it'll be turning all green and blue and different colors. That's because of corrosive stuff in the air attacking it. So that's where an epoxy dipped evaporator, or we might call them a coated evaporator, would help. Now, where I will say I have a problem with coated, there you go, Ralph. You can be my Copeland engineer for the show. Where I will say we do have a problem with coated is when they coat condenser coils, especially if the fins per inch are really high. So the fin spacing is very small. When they have coating on them, after about 4 or 5 years, or after you do some really heavy duty cleanings with condenser coil cleaners, it'll start to peel the coating off the condenser coil, and it'll actually block the condenser, and it's hard to get that coating to come out because the fin spacing is so small. So I have some situations where you try to blow the loose coating out with like CO2 or nitrogen or whatever, and it just doesn't come out, and it causes high head pressure issues. So that's some of the coatings I really am not a fan of, especially when they use the epoxy coatings on condensers. I've seen it done. It's kind of silly. Now they have some better ones that aren't really an epoxy, and they work better on condensers, but you see that like near the coast a lot. So POA can go hotter, but it's still not good. Yeah, definitely, John. What's my experience? Okay, I already answered that one. Okay, is that measured 6 to 8? Yeah, that is. I believe that is, Bill, is the 227 or 225, 6 to 8 inches away. Evan, your boss has you check temporize during your PMs. Okay, how many HVACR branches careers are there? I've heard the HVACR industry is huge. Jesse, there's too many to list. I mean, you have residential, you have, it just really, there's so many different areas of HVAC you can go into. You can go into building performance, which is a whole new emerging sector in our industry right now, where people are going out and selling indoor air quality products. They're fixing air leaks. That can go into like the construction side and the home remodeling side too. You can do building performance. It's kind of a harder sell in restaurants, but they do building performance in big giant office buildings and different things like that. There's so many different sectors of this industry. So then you've got the refrigeration side, you've got the air conditioning side, but then within the air conditioning and refrigeration side, you have scientific refrigeration. I mean, industrial refrigeration, industrial air conditioning. You could just keep going. We could talk about this for hours. There's so many different ways you can go within this industry. So let's see what else. Let's see. You have 2 dumb, curious questions. Hey, maybe Curious HVAC guy can answer your curious questions. All right, let's see. What is the best evaporator, and how do you make the evaporator much cooler? Ice Machine Rookie. Well, that's really kind of a hard question. There's really I can't really answer that one. I would suggest you send me an email and we can talk about that some more, and I can get some context about your question, because that's kind of a really vague question, but it also doesn't make sense. So yeah, just send me an email. It's not a stupid question. Just send me an email to hvacrvideos@gmail.com and I'll try to answer it for you. So, all right, let's see. Have I slowed down? Ernesto's asking me. Yeah, we're definitely slower right now. This week is always slow for us. But this is my favorite time of the year, because I get to be home with my family a little bit more. I get to spend some time with my kids, but the holidays right now, yeah, it's definitely slower. Definitely. Let's see. You're an HVAC building engineer. Right on, bud. All right. How do I recommend cleaning greasy condensers on self-contained units in restaurants? Storm. So usually what I do is, if I can, I'll go get a super shallow pan. Sometimes they have pans that are, 4 inches tall, and I'll slide it underneath the reach-in, or I'll pull the condenser out if it'll slide out and kind of tilt it, let the weight of the compressor kind of lean the condenser off the reach-in, and put a pan underneath it and then clean it. Sometimes you can't do that, and you just got to let the kitchen management or the chef or whatever know that, hey, I'm going to make a mess, and just go to town. Clean them with hot water. I prefer to clean condensers with hot water as much as possible, unless it's just light lint that you can brush off. And then if hot water doesn't take care of it, then I'll put a chemical on it, like the Hvacr HD cleaner, or you can even go with like the heavy duty degreasing cleaners too. New Calgon. Refrigeration Technologies makes one too. I think they call it Coil Bright or something like that. So, but yeah, sometimes you got to get the restaurants dirty. I try not to, but sometimes you got to do it. So, let's see what else we got. Let me see. Yeah, Bill, you should definitely take Ralph up on that offer to do training. That would be awesome. What kind of pressures do I get on treated condenser coils R22 and 410A? That's a good question. I don't know, David Air Conditioning Solutions. I mean, really, the pressures are going to be dependent on the outdoor ambient temperature and the coil TD. So, but treated condensers, I'm assuming that you mean like with coating on them. I don't know those numbers off the top of my head, but I mean, theoretically, if the manufacturer has a coil dipped, it shouldn't affect the TD. So, they should be using coil coatings that are very, very, not very invasive basically, and they're not going to affect the coil TD. So that's the hopes. If you have one that's really affecting your coil TD and it's causing higher than normal condensing temps, then that's a problem. So I don't, you can send me an email. That's kind of a hard one to answer on here too. So, all right. Are they using CO2 in California? Yeah. CO2, we're not using it in the restaurant side, but it's huge in the supermarket side right now. It's really emerging. And the companies that have jumped on the bandwagon to get trained and work with the CO2 are definitely ahead of the rest because it's becoming a very popular refrigerant. Ironically, with the CO2, it's a transcritical systems, I believe is what they call them, because they go super, super high pressure. But you still, again, I'm not super smart with those, but I believe you still have to use a secondary gas to cool it down, right? Which is, interesting. But yeah, I have no business even talking about CO2. So how do I feel about ticket time, paid for call versus hourly pay, feed Dizzle? So I am a time and materials company. We don't do any ticket time or, we're paid by the hour. All my employees are paid by the hour, basically. So whatever they work is what they get paid, and whatever we work is what we bill the customer. So we don't do any flat rate or anything like that. I don't want to knock anybody for doing flat rate and different stuff like that. It's just, it wouldn't fly in the commercial side here in Southern California. I definitely see some benefits to doing flat rate on the residential side. In my head, again, I'm not knocking anybody for doing it, but in my head, flat rate doesn't really make sense to me. Well, no, not flat rate, but the whole paid per the ticket or whatever you were asking, like that doesn't make sense to me. Paid per call, and for employees, I think you should get paid by the hour, but I'm sure that it benefits the employees sometimes. So, I don't want to knock that. It's just not something that I deal with regularly. So I'd have to talk to someone and have a genuine conversation on how it works out. But here we pay our guys hourly, just like that. They get overtime after 8 hours. And here, and I know it's different than other states, but in California, if you work over 8 hours, you get overtime. So I know in some places, if you work over 40, you get overtime. So over 8 in California, you get overtime. Over 12, you get double time. And that's how it works here. All right. How can I make a condenser hotter? Ice Machine Rookie. I don't know, bud. That's kind of a hard question to answer. How can you make a condenser hotter? You could reduce the heat reject. No, yeah, you reduce the airflow from the condenser fan motor, I guess, or you can make a condenser dirty so it's going to get hotter. That's kind of an interesting question, bud. So I think that send me an email, because you've got some other things to ask me too. So definitely ask me in the email, and we can try to talk about it a little bit more. So let's see what else we got here. Yeah, block it off. That's how you can make a condenser hotter. All right. Dallas fan. Okay, so hey there, Chad. How you doing, bud? All right, let's see. Does anyone have any suggestions for learning controls online? Eric Goldhammer. Yeah, I do actually. Go to a website called HVAC. Well, first off, depends. If you're in California, go to a website called itsaboutq.com. And if you're not in California, go to HVACR.edu. And they have a controls course that oftentimes is subsidized. In California, I believe it's subsidized by the utility companies, and you can learn controls online. You get a book and all that good stuff. But yeah, definitely check out that website. It's the same company, but It's About Q is the California website, or HVACR.edu is the everywhere else. And I believe you can do HVACR.edu in California too, but they have a lot of online learning, and a lot of times it's subsidized by the utilities in your area. So let's see. Have I ever done work on VRF systems? No, I have not, David. Am I a fan of memes? Yeah, memes are funny on Facebook and different things. Okay. Another question I get all the time. I'm going to go to my sheet right here, guys, real quick. Constantly get this one. Is why I'm so crazy because I wear my wedding ring at work, and I'm being dangerous, and I'm going to get electrocuted. And, I get so many different comments about that. Guys, I don't know how many times I can say this, but my ring is silicone. Okay. It's a silicone Qualo ring. QALO. You can order them online. There's tons of people that make silicone rings. The cool thing about the silicone rings are $25 or something like that, for a nice one, and you can get all kinds of different colors. But I don't wear a metal ring. I wear a silicone ring, so that way I won't get it ripped off. What do they call it? The finger ablation or whatever, where they like rip off the finger skin or whatever. That's what I don't want to happen. So that's why I wear a silicone ring. Okay. So I'm not wearing a metal conductive ring. I'm not going to get electrocuted. So let's see what else. Which is better, a heat pump or a gas furnace gas pack? HVAC kid, it really depends on where you live, bud, and how much your fuel costs are. So in Southern California, heat pumps are starting to get more and more popular as different municipalities start making it harder and harder for people to bring natural gas in. And I know that's like a trend right now in some of the yuppie cities where they're trying to push out natural gas. There's a few like super liberal yuppie cities in California where they're really pushing natural gas out. But in other parts of the country where natural gas is not feasible, you know, they use oil for heating. And then in some parts, like down in Florida, they have a lot of heat pumps where they don't have a lot of heat. So it really depends on your climate, and what your fuel costs are will determine which one is better for you. You know, there's goods and bads to heat pumps. There's goods and bads to, combustible gas furnaces, basically. Okay. So it really depends, on your climate and, you know, what your fuel costs are. That's what it comes down to. So, let's see. Let's see. You asked me a question on my walk-in doesn't work in cold video. If I didn't answer your question that you had sent me like on a thing, just send me an email. It's best to send me emails if I don't answer comments or anything like that. So hvacrvideos@gmail.com, and I'll try to get to any of your questions or comments. So let's see what else. You wore a wedding. And Zach, I wore one for a long time too. And it was just within the last like 3 years, I went to this silicone ring. So yeah. When social media got real popular and you saw those pictures and videos floating around of people's fingers coming off and different things, that's when it really got me thinking. But yeah. All right, let's see what else. All right, okay, so I'm going to, I'm just looking at my list right here. I already talked about why I don't show the entire process in my videos. One of the things too, guys, I make mistakes just like you guys, okay? I make mistakes all the time. I have no problem whatsoever with people pointing out mistakes. Again, you're not going to offend me. If you guys see something that I did wrong in my video, don't be a dick about it, but point it out. I got no problem with that. I'm open to all feedback, okay? And I know I make mistakes all the time, guys. I am not perfect whatsoever. So if you guys think I'm some like, you know, super tech, I'm not. I'm just a normal dude that makes mistakes, and I try to learn from them. So, but don't hesitate. I welcome feedback, good or bad. I welcome criticism. Shout it out, throw it in there. Just don't be a dick about it. Because a lot of times, like, someone had criticized me about something I did, and I had no problem with it. I left it on there, and I was about to acknowledge it, and someone else in the comments attacked the guy. You don't need to attack him. I mean, whatever. I usually handle comments, you know, negative or positive. I usually address them. So, but yeah, I'm totally open to it. Anybody has things, you know, throw it in there. Okay. Someone had asked me about Manitowoc ice machine fan cycle switches. Why do they fail so much? Manitowoc ice machines on their well, actually on all their ice machines, whether it be a traditional remote or a cool vapor defrost remote, okay, a quiet cube machine, they both have fan cycle controls and they both have head pressure control valves. When you're dealing with ice machines, they need to operate properly at really low ambient temperatures, and they need that discharge gas or cool vapor to warm up the evaporator to help defrost the ice. So we need that that warm gas from the condenser, basically. So we have to use a head pressure control valve, and we have to use a fan cycle switch. Now, the fan cycle switches, why do they fail so much on the Manitowoc machines? Well, it has something to do with the manufacturing and the quality of the switch. But you also have to understand that on a Manitowoc ice machine, let's just say a cool vapor, a CVD machine, quiet cube machine, that machine makes ice every 14 minutes. So every 14 minutes, it makes ice at the most, sometimes even sooner, in a day. So if you figure, you know, someone can do the math real quick. In a 24-hour day, that machine is going to harvest, you know, however many times, if it's making ice let's just say every 15 minutes, basically. So every time it goes into a harvest, that fan cycle switch is going to open and shut the condenser fan motor off, and then it's going to close Okay. If you have dirty condensers and different things like that, it's going to cause the system to run higher amperage, and it's going to cause the contacts inside that switch. But on top of that, you know, they obviously, Manitowoc has a problem with the switches that they have been using, and they've tried to fix it, and even the new ones fail a bunch too. What I usually do on the Manitowoc ice machines, and I'm addressing a question, that's why I'm bringing this up, but what I usually do on the Manitowoc ice machines is usually, if it's out of warranty, I put in a Johnson fan cycle control, like a aftermarket one, and it'll last forever. That has an actual capillary tube on it, and it's not the little peanut style, and then they last forever. So anybody that works on ice machines, you guys are going to know what I'm talking about with the fan cycle switches on the Manitowoc's. They fail all the time. So, and it's just manufacturing quality. So, yeah, definitely. I'll post Ralph's email right now. Let me see. Here we go. And Control V. One of these days, I don't know how I make it to where you can actually post things. I need to figure that out, Ralph, to where you can actually post your email in here. What's my take on VRF systems, and do I work on them, David? No, I don't work on VRF systems. It's just not something that I've been able to get trained or start working on. I think they're cool. I do think it's a little bit ironic because long time ago, we went away from running refrigerant lines all over buildings. So like high-rise buildings and different things like that. We went away from it and we went to chilled water, and we decided to confine the refrigerant to the mechanical room, like in the chiller or whatever, right? And then it just cools water or glycol and pumps it all over the building. But here we are, we're going back to running refrigerant lines all over the building. I think it's great, the efficiency's there and the technology's there, but it's just funny because, you know, we used to have refrigerant lines running all over the building and we had leaks like crazy. Then they went to chillers and pumping water and different stuffs. And then now we're going back to running refrigerant lines all over buildings instead of using a chiller and cooling towers and different stuff like that. But I definitely think VRF technology is great. I have no problems with it. I'd love to learn more. It's just one of those things where it's been hard because we don't see it in the industry that I work in very much, which is restaurants. So let's see what else. Do I consider equipment junked, and how do I explain that to the customer? Storm. So I work for chain restaurant, Storm, and the easiest way for me to explain things to chain restaurants is, let me explain this to you. Sorry. I'm kind of saying explain a bunch of times, but most chain restaurants buy their own equipment. So I'm not selling them a new air conditioner for the most part, okay? I'm not selling this chain restaurant, whatever chain it may be, a new ice machine. They usually buy them direct from the manufacturer. It sucks, but that's life, okay? I'm usually just selling them the miscellaneous, needed installation materials and a disconnect switch and my labor. So it's really easy for me to go to a chain restaurant and just say, look, this unit is going to take $1,500, little reach-in cooler, $1,500, $2,000 to change the compressor, the evaporator, and whatever. I think you should replace it. I'm not benefiting from that if they replace it. So that really helps me to tell a customer to buy new equipment. Now, when it comes to a customer where I'm going to sell them equipment, sure, it becomes a little bit harder for me to push a sale on them because they want to repair it versus spending, they see the value right now. Let's just say I'm going to change an air conditioner and whatever. I'm going to throw a number out there that it's going to cost $15,000 to change, but it only needs $5,000 in repairs. The customer sees it as, I can either fix it for $5,000 or change it for 15. That's the way they see it. So that is a hard sell. And usually we try to educate the customers in that situation where if I'm actually selling them a piece of equipment to say, look, I'm not going to guarantee my repairs. The equipment's old, it's got R22 refrigerant, the prices aren't too bad right now, but the costs are going up, different things like that. So I'll usually approach them with the facts. And I'm going to be honest with you, most customers don't want to replace equipment, especially here in California, because it's so difficult for us to get permits to replace equipment the correct way. So it's a hard sell. But on the chain restaurants, it's a really easy sell because they're buying the equipment themselves and I'm not benefiting other than an installation. Usually I'll make more money if I fix it, but then I don't want them to come after me a month later and say it broke again, and it's like, I told you guys not to fix it. So I try to push them to replace equipment as much as possible when it comes to, old stuff. So, all right. Let me see. HVAC computer. I'm not sure what system. Okay. Let me see. You lost 100 pounds of 410A from a roofing nail on a VRF. That sounds interesting, Bryce. How you doing, Bryce? I know Bryce. Bryce, not many years ago, Bryce used to actually work for us. So he got a much better opportunity to go work for someone else, and I think you made a good choice there, Bryce. So you're all right. All right, let's see what else we got here. If you start posting videos, can Honeywell be your sponsor? HVAC Heatmaster. You know, a lot. It's interesting that a lot comes from sponsorships. You know, I battle with sponsorships in my head. I have a sponsor. Spoiling is my sponsor for my videos. Okay, they're not a sponsor for the podcast, but it all works out. But I struggle with sponsors. So, you know, as you make videos, it's kind of a hard thing because you got to think about the person that you're asking for a sponsorship. What are you going to give to them? What value are they going to get from you? And then also you got to think about as a creator, you know, I got to think about, hey, I want to post this silly thing on Instagram or Facebook and it's not quite appropriate. Is it going to piss off a sponsor? Is it going to make them look bad? You know, different stuff like that. So sponsorships are a double-edged sword when it comes to doing that. I know you weren't asking me that and I just went off on a tangent, but all right, let's see what else. All right. Let me see. I'm just looking through the questions and comments here. If okay, I mentioned once the use of R290 condensing systems with glycol as heat transfer medium to keep combustibles outside. Have I heard of manufacture? Okay, so retread. That was a thought in my head that I see where in the future with as crazy as we're getting with our refrigerant requirements and all that different stuff, I predict that in the future we are going to have small chillers on residential systems that have flammable hydrocarbon refrigerants outside, and we're pumping basically glycol into the building. I predict that's where we're going to go because of the way that we want natural refrigerants and different things like that, and we don't want to make refrigerants that harm the ozone layer. But I'm sure that we're going to figure out that R290 is, you know, whatever. We're hurting the environment by pulling R290, you know, who knows? We'll figure out a way to ban that too. But I do predict, and I'm surprised we haven't seen it yet, where we have chillers and we keep the hydrocarbon refrigerants outside of the residence, and then we just pump a secondary coolant into the residence on a, you know, glycol or something like that. I think that's going to come. I wouldn't be surprised if it's sooner than later. So, all right. Zach, if a cooler was down for a while and product became warm, could that affect superheat and subcooling? Well, on a hot pull down, sure, your superheat and your subcooling is going to be affected. You typically don't want to check your superheat until your system is close to being stabilized or down to temperature. Because if it's got an expansion valve, as your system's under a heavy load, the expansion valve is going to be wide open and your superheat's going to be, you know, out of whack, basically. So you want to let your system stabilize out. Yes. You typically don't want to check your vital signs until it's stabilized out and pretty darn close to being down to temperature. You can definitely pay attention to your subcooling because your subcooling should not be through the roof, but you always want to let a system stabilize out before you start analyzing anything. So, all right. HVACR Heat Master. You love tree huggers. You should come to California if you're not already, because there's lots of tree huggers here. So, all right, let's see what else. What's my approach on remote systems in restaurants during rush hours when unit isn't temping? What do you mean? Give me some context on your question there, bud. How was the HVACR Expo? Ernesto asked me, HVACR vlogger. So we have a local trade show. It's called the iHacky Trade Show. It's one of the accredited, whatever, just one of our regional organizations, Indoor Heat and Air Conditioning whatever organization or association. Sorry if anybody's watching. I don't know the name, what the acronym iHacky stands for, but we have an iHacky trade show, and it's just a regional trade show where they have different manufacturers come out. I'm going to be honest with you. The iHacky trade show for me was more of a socializing thing, just going around saying hi to people and talking to other people that I haven't seen in a while. It's definitely a small trade show. It's not bad. I mean, it's held in Pasadena, California. It's usually in November every single year. It's cool. It's definitely been getting smaller and smaller. But it was neat just to go and socialize. I wouldn't say that there was anything that amazed me. I didn't see anything that was like, oh my gosh, this is this new product coming out or anything. It's nothing like that. You just have a few different manufacturers. Field Piece was there, and they had their new meters that they're coming out with. They haven't been released to the public yet, but they have their new meters on display. There's a couple different tool manufacturers, supply houses, refrigerant manufacturers, different things like that. So let's see what else. For restaurants, which is better, self-contained units or remote systems? So for restaurants, remote systems are better. They're always better because self-contained usually reject the heat into the space and they bring the building temperatures up. For the most part, remote systems can be remoted onto the roof and then they're not in a hot kitchen. Now, granted, they could be on a hot roof, but oftentimes we can oversize condensing units and do different things. We can, pre-cool them or whatever if we need to. So I prefer remote systems on restaurants, but remote systems typically have more refrigerant leaks. And you also have multiplex systems, meaning that you have one condensing unit that controls 5 different reach-in coolers downstairs. So each reach-in cooler might have 2 evaporators with 2 TXVs. So then you have lots of potential for leaks. So, both have their positives and negatives. If you can have a kitchen that's conditioned really well and it was designed for the heat of rejection from a lot of self-contained reach-ins, then you might be better and you would have less potential of difficult leaks to find because the leaks would be contained in the little reach-in. So, but oftentimes the reach-ins are added after the fact or kitchens are added onto. So the air conditioning most of the time, at least here in California, isn't really designed to cool the kitchen as it is. So any more heat you add in the kitchen becomes a problem. So, all right, let me see. Any advice for a new guys in the trade that did not take any school? Carlos, new guys in the trade. Well, yeah. And this actually kind of goes into a question that I got too, but someone had very similar to your question. So new guys that are coming in, this trade needs all the help it can get. But what it doesn't need is it doesn't need attitudes. It doesn't need, I need to go home early every single day. It doesn't need the me attitude. Okay. At the same time, new technicians and any other technician, you deserve to be respected by your company. You need to have a mutual respect between yourself and your company. But you can't constantly want everything. And again, I'm addressing the new guys right now. You can't come in here and expect to get paid top dollar because that's not going to happen coming into the trade. You're going to have to work your way up. But you should not be disrespected. You should not be hazed. You should not be, sent to go get stupid tools and different stuff like that and things that don't exist. Nobody needs to demean you or treat you like crap. But you guys need to come in here with a hunger to learn. You need to be respectful. There's lots of people willing to teach, but there's also a lot of grumpy people that don't want to teach. When you go, and this is for the new guys that are coming into the trade, when you go to work for a new company, what you need to remember is you don't want to go in there cocky thinking that your shit doesn't stink, okay? But you also need to remember that you're interviewing that company just as much as they're interviewing you, okay? The biggest suggestion I can give to any new guys, all right? And I'm probably going off on a tangent a little bit past your question, but the biggest advice is if you go to an interview, request that you do ride-alongs. Request that you work with them for a couple days. Now, understand something too. You're probably not going to get paid for that, and just accept that. Work with the company for 3 or 4 days. Just say, hey, I want to ride with different technicians, or I want to ride with your main tech, and I want to see what kind of equipment you work on. I want to see what I'm potentially going to be doing, okay? But just lose the attitude and just go in there, be humble, and be willing to learn, and you're going to go far, all right? Now, at the same time, too, just because you didn't go to school doesn't mean that you shouldn't go to school. There's no excuse for not attending night classes at a community college. You don't need to go sign up for a program that costs $30,000. You can go take a night class. It might cost you $300, $400 or something like that for the semester. The education, even if it's remedial stuff that it's probably going to fill in some gaps. So I highly suggest, no matter what, that you continue your education for the new guys coming in and for the experienced guys too. Go to night school, man. Take a class here and there, work it out with your company, figure that out. But for the new guys coming in, just lose the attitudes and just be humble and be like a sponge and willing to learn, and you will go far. So, well, I really appreciate that, Hamilton Mechanical. Thank you very much, man. All right. Hopefully I answered that for you, Carlos. I appreciate it. All right. Let me see what else. All right. What's the support stuff in green for? Oh, okay. Got you. All right. Beaver, it says, what's the support stuff in green font? So basically, people, my channel finally got to the point where they allowed me to turn on memberships. I'm going to address it right now for everybody that's curious. So memberships are kind of like a Patreon. You're supporting the channel on a monthly level. You don't have to do it. It's not required by anybody, okay? It's just a way to basically pledge that you're going to support the channel for $1 or whatever. I think the lowest thing is $1.99 a month or something like that. But again, you guys do not have to do it. I kind of felt weird even turning it on. I'll figure something out to where supporters eventually, I'll try to figure out a way to like do, you know, something where you guys get some kind of bonus or benefit or something like that. Again, I'm not super smart with all this stuff, but we'll figure that out eventually. So, all right. If I missed anything, guys, throw it in there again. I know there's probably stuff up there that I didn't attack or didn't hit up. So, all right, let's see what else. Let me see. I've kind of gone through my list here. I already covered that. Ralph is a good person to be in here because one of the things I have is as we're coming to the end of the year, guys, we have all kinds of new regulations coming into as concerning refrigerants. Too many for me to list off the top of my head. I don't want to blow Ralph up, but maybe we'll figure something out where Ralph and I can work together on something to do a video or something like that. But if you guys do have questions, definitely reach out to Ralph, okay? I'll post his email in here again, but all kinds of new restrictions and regulations coming up. You guys definitely want to pay attention because a lot of new laws are going to come out. There's a lot of misinformation out there too coming out as we come to the end of the year. Okay, I'm going to dispel the myth right now that R22 is not illegal. Plain and simple, guys. It is not illegal. There's a lot of misinformation being pushed by especially some of the more shady residential air conditioning companies. Okay, R22 is not illegal and it's not being banned. Okay, the production and the import of R22 into the United States is going away. So we're not going to be able to import R22 refrigerant anymore, and we're not going to be able to produce new R22 refrigerant. But we still have stockpiles of R22 refrigerant in supply houses. We still have recovered refrigerant that is cleaned, recycled, and pushed back out into the industry. So there's plenty of R22 to go for years to come. Okay, so I'm just dispelling the myth that it's being banned or that it's illegal. That is not true. Okay, now, of course, prices are going to go up. There's plenty of alternatives for R22 refrigerants and many of the other refrigerants out there too. For instance, here in the state of California, as of last year, as of January 1st of 2019, we are not allowed to use R404A refrigerant, which is one of the most popular medium temperature refrigerants on new installations of walk-in coolers, on retrofit, major retrofits of walk-in coolers and different things like that. So there's all kinds of regional regulations and different stuff going on. So pay attention to the regulations that are coming into your state. Several states are adopting new similar things to what California is doing with the R404A refrigerant. So definitely do your research, guys. Figure it out and don't just trust what you read on the internet, okay? Or someone said on a live stream or a podcast. You guys got to do the research yourself and figure out what it is. I challenge you guys. So, you know, the way that Ralph and I met was I had made a video about me working on an R404A walk-in cooler or something like that, I think it was. And Ralph had reached out through a mutual friend, Brian Orr, and got a hold of me and just said, hey, were you aware of this new change? And I was completely unaware that of January 1st, 2019, that R404A was no longer being allowed to be used on new installations in California. Okay, so furthermore, I didn't trust just what Ralph said. You know what I did? I called the AQMD, the Air Quality Management District or something, whatever our local, whatever regulation people are. And they were just as confused. When I called and I talked to one person and they said, yeah, you can still use 404. And then she said, but I'm going to transfer you. And she transferred me to another person. And he said, no, you can't use 404. And I went back and forth. So eventually I got a hold of Ralph again and we got everything worked out to where I understood the law and how things happen. So that's actually how Ralph got involved with these streams. And was he just watched a video and then reached out through a mutual friend. And we, we became internet friends, I guess you can call it. But you guys got to do the research yourself. All you got to do is ask the Google, and it will usually tell you a bunch of answers, and then you got to decipher which ones are true and which ones are not. And then start reaching out to people, manufacturers like Honeywell or whatever refrigerants you guys use. I'd be very cautious about just trusting what a counter guy at the supply house says, because some supply houses are ill-informed when it comes to certain things, but some supply houses, you got to understand, some know what they're talking about. So you guys got to know how to listen and understand and be able to interpolate if they are just blowing smoke up your ass or if they know what they're saying. Usually as you get into the higher ups at the supply houses, the regional managers and the corporate managers, they usually kind of have a better idea what's going on. Oftentimes your local supply houses will have websites that have all kinds of great industry information that most people don't even go look at. So I implore you guys to do some research and figure out the new laws and new restrictions that are coming out, because they're going to change per state, and all kinds of new stuff's coming out. All right. What I missed here. Okay. Okay. Let's see what we got here. Is it okay to use an AC compressor on a refrigeration application and vice versa? HVAC kid. It really depends on the temperature at which that compressor was designed. Now, remember I said something earlier that compressors are cooled by suction gas, okay? So lower temp compressors have different compression ratios. They tend to run hotter, okay? So they tend to require certain amounts of refrigerant coming back versus a higher temp compressor. But there is a difference between a low temp and a high temp compressor. So you need to read the manufacturer's information. Copeland and Tecumseh, I'm very familiar with. I know there's Danfoss and a couple other manufacturers, but Copeland and Tecumseh do a very good job of publishing their engineering data to let you know the operating envelope at which that compressor can operate. So it will tell you, it will put out this many BTUs at this condensing temp and at this evaporator temp, period. So then you can go do the math and say, okay, I'm running a walk-in cooler. We've got a 20-degree evaporator temp, and we have a potential, 120-degree design condensing temp. So that would probably be a 100-degree ambient with a 30-degree box temp, something like that. So you need to be able to look into the engineering data. You can also lean on your supply houses, but again, you got to be able to interpolate whether or not they know what they're talking about when they give you that information to tell you whether or not it can work. Okay, so yes, again, I went off on a tangent, but yes, an air conditioning compressor can be used for a refrigeration compressor, but it just depends on, some work better, some won't. Okay, so it just depends on the capacity and what it can deliver at what temperatures. So let's see what else. Have I done any hot side work before? Tool, tall, rich, tall. No, I don't do any hot side work. It's just one of those things where I stay super busy, and it's hard enough working with my guys with refrigeration and air conditioning to bring in a whole new division of hot side stuff. I just wouldn't be able to keep up. So no, I have not done hot side work. It's not to say that I couldn't, but it is a whole new world. If you understand the electrical side and if you understand the combustion side, you should be able to pick up the hot side stuff pretty quick, but it definitely is going to be some interesting stuff. A lot more greasy work. Although we work on a lot of greasy stuff too already doing restaurant refrigeration. So how do I make the condenser hotter, and do you make the evaporator much cooler? Because for a heat pump, you need the condenser to be hotter than the evaporator to remove cold air from the building. Well, to do that, Ice Machine Rookie, we're going to have a three-way valve or a reversing valve that's going to reverse the refrigerant flow. So basically, it's going to reverse the refrigerant flow, and the lines have to be sized correctly. So then the compressor is going to pump the high temperature, high pressure, superheated vapor from the compressor into the evaporator, and the evaporator then becomes the condenser. And then the condenser or the outdoor coil outside becomes the new evaporator. And it rejects, or yeah, you understand. It just reverses the process on a heat pump. So it's basically by the reversing valve is what's going to change the flow of refrigerant. So it's going to change the direction. So, it may pump, one going up, one going down, while the reversing valve is going to make it go, basically redivert it and pump everything around. My fingers are probably confusing the hell out of you. So let's see what else. All right. Let me see. Chad, thank you very much for that super chat. I really appreciate it. You guys, the people that are donating super chats and becoming members, you guys are awesome. Okay. Not expected. I do these streams and these videos, but you guys that are helping, it really does help the channel. So thank you very, very much. So, all right, let me see. What else have I missed here? Okay, yeah, I saw it there. I answered that one. Have I worked on any belt-driven compressors or wood coolers? Chris Cooley. No, actually, well, I'm not going to say, but yes, many. I'm sorry, I'm not making sense there, but no, I have never worked on a belt-driven compressor. I have seen a belt-driven compressor at a old university. I'm not going to mention the name, but an old university that before they did a remodel, they used to have an underground basement, and they had belt-driven compressors for all their walk-ins. I never had the opportunity to work on them, But I wish I could have. I wish I could have gotten my hands on them, but I've never worked on anything belt driven. Never worked on any open drive systems. My stuff is all just normal light commercial, 5 tons and lower, normal reciprocating and scroll compressors. You know, nothing too fancy. All right. Let me see. All right, let me see what I'm missing here. You heard propane is a good refrigerant. Yeah, propane is, I mean, it's a very efficient refrigerant. R290 is what it's called. It's definitely, there's some safety stuff you have to take into play. We have a lot of R290 systems coming into the restaurant refrigeration side, so there's tons of it out there. Everybody's having to get used to working on it. It's just following some new safety precautions, but it is very efficient. You get more bang for your buck, or whatever I guess you can say, because you're able to put smaller compressors, smaller condensers, smaller evaporators, and you basically get the same, if not more, BTUs out of the system, basically. So that's why they're able to basically, with 150 grams, which is our current charge restriction on R290 systems. Okay. So you can only have 6, 7 ounces of refrigerant in the system at the maximum. And they're able to do what, and they were able to have a smaller condenser, smaller compressor, smaller evaporator, and you could take that identical box that had 404A refrigerant that had 20 ounces of 404, a bigger compressor, and you could do the same work with it. So it's very efficient, but there's some safety issues there that you have to follow when working on it. You got to follow some proper safety precautions. It's really not that bad. I've got some videos. If you just Google search on, or even just look on YouTube, look up R290, and my videos are going to pop up. So you can even look them up on YouTube, or you can try to find them on my channel too. So, no, I don't have I should have Streamlabs alerts turned on. I probably don't. Let me see here. Bam and bam. There. Now I got Streamlabs turned on. I should have had them already on before, but yeah, they're on. There's a tip jar and a little thing. So yeah, something I should have done earlier. It's just one of those things I didn't. Did I see your email about Hoshizaki TXV heaters? If so, Robbie G, yes, I did see your email. So guys, Robbie had emailed me that he's been having a problem with I believe it was a Hoshizaki Reach-In or Hoshizaki Freezer, Robbie, I believe you said. And he sent me some pictures of the fix, and I think it's ridiculous. So Hoshizaki has a Danfoss TXV that keeps icing up, and it's plugging up the valve. To me, it sounds like there's moisture in the system, but apparently there's a tech review or something like that where they send out this little heater, and you wire in a heater around the expansion valve, and it keeps it from freezing up. It sounds like the silliest thing in the world. And I don't want to talk bad on manufacturers, but good grief. Why not just change the TXV and put a proper Sporlan TXV in there and call it a day? I'm sorry. I don't mean to talk crap about Danfoss, but if they're freezing up, again, it doesn't make sense that they're freezing up a TXV, but again, I thought it was like moisture in the system, but yeah, it's a whole trip, Robbie. That's really interesting, man. I can't believe that they sent out a heater kit to wrap around the expansion valve to keep it from freezing up. That's kind of bizarre. So, can hydrocarbon refrigerants self-ignite when compressed from heat and pressure in a compressor? No, Ice Machine Rookie. You are not going to get self-ignition because, okay, think about it. You need 3 components for ignition to happen, right? You need a spark, you need fuel, and you need oxygen. So you shouldn't have any oxygen inside your compressor. Your compressor's a sealed system, right? And you're not going to have that third component of oxygen. So you will not self-ignite inside a compressor. It's a sealed system with no oxygen in it. Now, on the flip side, there have been situations where if you look at, some Facebook posts and different things like that, where you've seen some mini splits and different things explode, and lots of people get hurt and some people, die from it. And I don't know this for a fact, but I have a feeling that a lot of it has to do with poor installation practices and bad things being done, contaminants being introduced into the system with hydrocarbon refrigerants, and bad things are happening. So no, if you follow proper refrigeration practices, you're not going to have a self-ignition within an R290 system, okay? Because you don't have that oxygen, to create the combustion, basically. So you have done like 10 of them so far, brand new units. It works, though. Yeah, it still just blows my mind, Robbie G, that they wrap a heater around the expansion valve. So where does the water from the evaporator go in your house refrigerator. So Ben, typically on your house refrigerator, the water is going to run into some sort of a, it's going to evaporate somehow. So typically, there's a couple different methods. Sometimes they'll have a, that was ridiculously loud. See, that's why I don't have, thank you, Ruben, but that's why I don't have that stuff turned on. That scared the crap out of me. Sorry if that blew anybody's ears out. Yeah, that scared the crap out of me, dude. Ugh. Thank you, Ruben, but whew, that scared me, man. Appreciate it, dude, but that's those stupid alerts. I hate those things. That's why I don't have those things turned on. Ugh, scared me. I'm going to turn the alerts off completely. I mean, you'll still see them pop up, but you don't hear the sound. Ugh, sorry about that, guys. Yeah, exactly. It freaking scared the crap. Do you guys see me jump? I hate those stupid alerts, but I turned the volume off, so that won't happen again. But so the condensate from your evaporator is typically evaporated. So there's usually a condensate pan, and they might have a wicking material that soaks up the water, and then the discharge from the condenser, the air coming out of the condenser will evaporate the water, or sometimes they'll have a hot gas condensate loop. I'm probably talking Chinese to you, but they'll have a hot gas condensate loop that evaporates the water, but somehow that water is being evaporated. So is what's going to happen. So, all right, let's see what else. Check my Streamlabs donation. Oh, dude, Jeff, thank you very much, man. I really appreciate that, Jeff. That was awesome, dude. I do see that actually in here right now. It's popping up on my feed, but it didn't pop up on here. So thank you very much, Jeff. That was super awesome that you did a Streamlabs donation. Again, thank you. You guys that are doing super chats, you guys are freaking amazing. Thank you very much. Okay, super chats, Streamlabs, PayPal, all those different things. Thank you very much, man. I'm super blown away by those. I'm still shaken up by that stupid notification that came in my ears. So JJ Services, thank you very much, man. Have I thought about why reversing valve switches? Wait, have I thought about why the reversing valve switches despite the 24 volts staying present? No, Ike, that sounds like you got a bad reversing valve, dude. You were the one that had messaged me about that last week, right? Yeah. Why is that still doing that? It scares the crap out of me. Yeah, I'm going to turn those off. Sorry, guys. Off, done. Again, sorry. Ugh. Scared the crap out of me in my ears. I thought I turned the volume down and it still pops in there. This whole streaming thing is weird. So, all right, let's see. It's only because I always skip the ads, man, and you watched a ton of my videos. Oh, thank you very much, Jeff. I really appreciate it, man. So, yeah, another way too, guys, for those of you that are, and again, it's all good, Jeff. I don't mind you skipping ads. That's cool. But that's another way too, is I really appreciate if you guys could share my videos with other people. Okay, yeah, I turned it off. See, you're not going to blow my ears this time, Adam. So, boom, done. Yeah, if you guys could share the videos with other people, I'd really appreciate that too. Helping the channel to grow, it really helps me. So, all right, let's see what else we got. Smoke system thing. Why the hell is that still popping up in my ears? You guys are driving me nuts right now with super chats. I would never say this, but it's driving me crazy. Why the hell did that still popping up in my ears? Damn it. I don't know how to turn these things off. I do not know how to turn them off. Oh, man. This is driving me crazy. Yeah, it worked. Yeah, thanks, Adam. I really appreciate it. Okay, so I transitioned this over. This should not be doing that anymore. I turned the dang things off. All right. Anyways. Scared the crap out of me, Adam. So, all right. Yeah, let's do an hour of alerts. Please don't. Oh, man. Do I have any choice of the ads that appear in my videos? No, Dave Johnson, I do not. So basically, I can control the amount of ads, and I think in the beginning I used to put way too many ads in there, but I realized, so I cut them down. So I think at the most I ever put in a video is 2 ads. I try to put just 1, but I can't control what they show. So if they're showing you an ad for freaking whatever, Viagra or something, it has nothing to do with me. It just pops up. There you go, Ralph. See, I'm ready. Is this gonna pop in my ears? Okay, I think it's fixed. I don't think it's making sounds anymore. I think I fixed it. See? See, guys? No! Oh, fuck. Pardon my French. Oh, wait. There we go. Maybe that fixed it. Mute event sounds. I think I fixed it. Yeah. Anyways, can I explain how the smoke system thing works on my wood board behind me? Oh yeah, that's just a smoke detector. So basically, it's like a smoke detector in your house, and then it didn't work, as in go through to Chris, and his account has keep go. Oh yeah. So that's just a trainer board that I set up for my own employees. I have a video on it. If you look up duct detector on YouTube or search it within my channel, it shows it. But that's just a trainer board so I can show people how to wire in. No, I'm not doing it on purpose. See, I turned it off now, Adam. See, I won. So, yeah, if you guys see, there's a PayPal thing coming through too. So thank you very much. But if you have if you search up on my YouTube channel, duct detector. But this right here is just so I can simulate for my guys. You know, this is how a smoke detector works. And, you know, this is what it does when it shuts them off. But Google search on my channel, duct detector, and you'll see it. Or even just look up YouTube, duct detector. So, Hockey Hunter has a question. Did I miss a question? If I missed a question, post it again, and I will definitely try to get to it here. See what I missed. Let me see. My phone is going crazy with emails and different things right now. I don't see Hockey Hunter. I don't know. So just post your question again if I missed it, okay? Oh, there you go. Did I go through an apprenticeship, and do I think it's fair to send a second-year apprentice on their own on things they don't know? Okay, so here, great question, Hockey Hunter. Okay. Yeah, so I did not go, well, no, I mean, I guess you can say. So I started working for my father. So I didn't go through a proper apprenticeship, but I grew up working in the trade, working with my dad. I learned, you know, lots of bad things. I learned lots of good things. I also learned from my cousin who used to work for me too, and he was a mentor of mine and taught me a lot. And at the same time, I went to night school at the community college. So I had 3 different ways of being educated. I did not go through an official apprenticeship. I do agree that people do need to go through a proper apprenticeship. I try to give my guys, I can't give my guys a 2-year apprenticeship, but you know, for the most part, I bring on people that come in as an apprentice with me, and they'll typically ride in my van for, you know, a couple months, and then I'll usually put them in a van, and then they'll start meeting me places, and I'll slowly work them up. I don't throw them to the wolves. I'll start them out on a preventative maintenance, that kind of stuff, cleaning coils, learning why coils need to be cleaned, and that, you know, that kind of stuff, and then work their way up. I am not personally, again, I'm not judging anybody, but I am not a fan of throwing people to the wolves. I don't like it because that's what was done to me, and it was really difficult, and I made lots of mistakes, and it worked out, and I learned from them, but I just didn't like the way that it went down. I know that a lot of people have learned that way, and a lot of people agree that people need to learn the hard way, okay? But I like to build people up and give them the proper tools so they know how to, they can see me interact with customers, so they can see the way that I expect them to. So again, no, I did not go through a proper apprenticeship. If you don't feel comfortable with someone throwing you out to do service, then you need to say something, okay? You shouldn't be in a position where you don't feel comfortable. You should be comfortable with what you're doing. At the same time, you can't expect big dollars to be paid to you if you're not out there doing your own work. So it's kind of a give and take, okay? So obviously your pay is going to be a little bit lower, but you're gonna shadow someone a little bit longer. Right now we're so hungry for techs that I find a lot of companies just throwing people out there, you know? Yes, it is really fixed, Andrew X192. Thank you very much, though, for that super chat. I appreciate it. But yeah, there's a lot of companies out there throwing people out there when they really shouldn't be thrown out there. So, you know, it is what it is, but I'm not a fan of that. I like to bring people up the proper way. So, all right. Guys, don't forget, thanks for reminding me there, Bill. Check out the HVAC Overtime show. There's a lot of the Overtime guys in here. Adam's in here, Justin's in here, and I think Joe was in here too. And Zach was in here too. But it'll be on the Tradesman Shop Talk channel. Okay? Justin, if you could post a link to that, I don't know if you have it handy. Definitely a good time, or good thing to check out on Friday night, okay, guys? Let's see. What am I missing? Any good advice for someone how is starting a company? Ooh, starting a company, Aldo. That's, I mean, you really need to, hopefully you got the industry figured out and the trade figured out. You know, read a lot of business books. What I would highly suggest you do is check out my buddy Tersh Blissett. He has a podcast called, help me guys, remind me what the name of Tersh's podcast is. Gosh, it's slipping my brain right now, but come on. What is Tersh's podcast? Someone will post it in here right now, what Tersh's podcast is called. And it's basically about starting a business, And he actually started his own business and started the podcast and then started talking about the things that he did and how he worked his way up. So I definitely suggest checking out Tersh's podcast. It's definitely a great, great thing to check out. Service Business Mastery. There you go. Service Business Mastery is the name of Tersh Blissett's podcast. So check it out. If you're starting up a business, there's probably great information on there. Also at the same time, my buddy Gil over at HVAC Uncensored throws out a lot of great knowledge about business, and they do a lot of good stuff on there too. So HVAC Uncensored podcast, check that out too. All right, what happened to the big boy in overtime? Rookie refrigeration. Mike decided to go his own way. That's all. They still all get along. Mike just decided to do his own thing. So no, there's no bad blood there. All right, Business Master. Yeah, exactly. Okay, cool. How do you become a member on mobile? Jeff Goley. It should have it on your phone. Again, I'll show you real quick. So if you click on, guys, if you click on right here, like I'm watching the stream. If you exit out of the chat, this is an Android. It tells you subscribe or join if you're not subscribed. So all you got to do is click join, and then it says it. So if you're in the chat, like right now, it's showing the chat. That's on my phone. You just hit the back button, and it should show you. So I'm sure it's the same on Apple too in some way or the other. All right, guys, I've just about run out of stuff to talk about. The phone starts talking in the background. I've just about run out of stuff to talk about, so I'm going to go ahead and wrap this up. I really, really appreciate you guys coming in here. Any questions? I'm sure there's lots that I didn't answer. Send me an email to hvacrvideos@gmail.com. Oh, that's interesting. So it doesn't pop up on iOS. Oh, yeah, then that's just I'm not an Apple fan, so. But I really appreciate you guys coming in here. Thank you so very much. Do me a favor. Check out Justin's throwing up some links to some of the other shows and different things. Okay, you got there's lots of people in here that have YouTube channels. Check them all out, guys. We need to figure out a way, guys, that I can promote your guys' channels somehow. Maybe we'll do end credits or something like that where I show my friends or something. We should try to do that. But yeah, so I really appreciate you guys coming in here. I'm gonna go ahead and click up my outro music, and we're gonna catch you guys on the next one. Okay.